Hello, students. This recording is for Unit 14.6. We're going to talk about surface area and volume of spheres. So let me share my writing screen and we'll get started. All right, surface area and volumes of spheres. The first thing we need to do is look at some of the vocabulary for this unit, just so that we're all talking in the same language. In spheres, you have the center of the sphere and the radius. So the definition of a sphere is going to be all the points in space, so three-dimensional space, that are equidistant from a given point, and that's the center. And then the radius is the segment that has one endpoint on the center of the sphere, and the other endpoint is on the sphere itself. And then the diameter would be a segment that passes through the center that has its endpoints on the sphere. Now, an important thing that we talked about in some of the other lessons in this unit has been what would happen if we were to intersect a 3D figure with a plane. What shape would we come up with? Well, when a plane and a sphere intersect in more than one point, the intersection is always going to be a circle, okay? And if the center of the circle is also the center of the sphere, the name we call that is the great sphere, in part because it's going to be the largest sphere, the great circle. It's going to be the largest circle that you can find in a sphere by passing a plane through it. And so then the circumference of that great circle is also considered to be the circumference of the sphere. And the great circle divides the sphere into two halves. Okay, so some things that you need to be sure to know from this unit are going to be how to find the surface area and volume of a sphere. Okay, surface area and volume of a sphere. So surface area of a sphere, and you should add this into your chart. Surface area of a sphere is based on the area of the great circle in the sphere. So, oh, I am not happy about that. All right. The surface area of a sphere is 4 of the areas of the great circle. So surface area of a sphere is equal to 4 times pi r squared. So if I were to take the circle that's in the center and put that over the outside or the sphere itself, there would be 4 of them. Okay, volume. Volume for a sphere is going to be 4/3 pi r cubed. Okay, so those are the two major formulas that you need for this unit. So let's look at an example. Problem 1. Finding the surface area of a sphere. What's the surface area of the sphere in terms of pi? So in this sphere, we have a radius, or a diameter actually, of 10. All right, so surface area for this sphere. Surface area is going to be 4 pi r squared. And our radius, the diameter is equal to 10. And so our radius is going to be equal to 5 meters. 4 pi times 5 squared. So that will be 4 pi times 25, which is 100 pi meters squared. Okay, an important thing here to note is, can we calculate the lateral surface area of a sphere? Lateral surface area. Unlike cones, cylinders, pyramids, and prisms, there is no such thing as a lateral surface area. It does not exist. The reason for that, of course, is that there's no base, right? A sphere does not have a base, so we cannot distinguish in in the surface area of a sphere between the base and the sides, the lateral surface areas. So the lateral surface area does not exist in a sphere. Okay, problem 2. The Earth's equator is about 24,902 miles long. Okay. The Earth's equator is about 24,902 miles long. What's the approximate surface area of the Earth? Round to the nearest 1,000 square miles. Okay, so the circumference of the Earth, or of the equator, right, is 24,902 miles. So find the surface area of the Earth. Okay, so from this, we can get the radius of the sphere. And once we have the radius of the sphere, we can plug that into surface area equals 4 pi r squared. So getting the surface area, well, circumference is equal to 2 pi r. And so then we would say 24,902 equals 2 pi times the radius. Divide both sides by 2 pi. And we get 3,963. When you put this into your calculator, it's really important that when you do 24,902, if you do that divided by 2 second function pi, that's the answer you get. However, if you do 24,902 divided by parentheses 2 second function pi close parentheses, that's the answer you get. So what happens is, if you don't put that 2 pi in parentheses, this is something you need to watch out for, your calculator is going to divide by 2 and multiply by pi. You have to use those parentheses to make sure your calculator knows the correct order of operations. Alternatively, if you don't want to use parentheses, you can also do 9,002 divided by 2 divided by pi. And that way you're saying, okay, I want you to divide by both of these. Either one of those would work. You just have to communicate with your calculator in a way it understands. Okay. If I plug this in for r, I have 4 pi times 3,963 squared. So I'm going to do 4 second function pi times, I'm going to go up here and hit enter, squared. And that gives me a humongous number. Then I'm going to round to my nearest thousand, so 197387000 miles. 193,387,000 square miles. Okay. All right, let's find the volume of a sphere now. Problem number 3. Okay, volume of a sphere. Find the volume, what is the volume of the sphere in terms of pi? So here we have a radius of 6 meters. So volume is equal to 4/3 pi r cubed. We plug that in, and we get 4/3 pi times 6 cubed. We're doing this in terms of pi, so we do 6 raised to the 3rd power times 4 divided by 3 equals 288 pi meters cubed. Okay, find the volume of a composite figure. Let's take a look at this one. Okay, so we're going to find the volume of this composite figure, which is a combination of a cylinder and a hemisphere. Half of a sphere is called a hemisphere. So let us sketch that and then calculate it. Volume of a composite figure. Okay, so it says that the diameter is 3 inches and the height of our cylinder is 5 inches. All right, so our volume is going to be equal to a cylinder plus a hemisphere. Okay, so the volume for a cylinder is pi r squared times the height. And the volume of our hemisphere is going to be half the volume of our sphere. So if the formula for the volume of a sphere is 4/3 pi r cubed, then half of that is going to be 1/2 times 4/3 pi r cubed, which will be half of 4/3 is 2/3 pi r cubed. So I'm going to have 2/3 pi r cubed down here. Okay, so plugging in, I have pi times my diameter was 3, so my radius is going to be 1.5. 1.5 squared, my height is 5, plus 2/3 pi. In this case, my radius for the hemisphere is the same as the radius for my cylinder. So pi 1.5 cubed. This does not ask for it in terms of pi, but let's find our answer in terms of pi first, and then we'll multiply pi out. So 1.5 squared times 5 equals 11.25 pi plus 1.5 cubed times 2 divided by 3. Uh-oh, that didn't work out well because it didn't come out of my exponent. Times 2 divided by 3. So that's going to be 2.25 pi. When I add those together, I get 13.5 pi. 13.5 pi is equal to 42.41 inches cubed. And this wanted us to round. This actually has a second part to it. So if this is our volume, what is the weight? In ounces if salt weighs 1.25 ounces per cubic inch. That also is its density. Weighs 1.25 ounces per cubic inch. Okay, so to do this one, I take my cubic inches and I multiply it times my density. So weight is equal to density times volume. So it will be 1.25 times 42.41. Oops. 1.25 equals 53.01 ounces. Okay, those are all the example problems for this unit. This unit is pretty straightforward. You're going to be asked to find surface areas and volumes. Okay, then also not just for theoretical spheres, but actual spheres. You might need to be thinking about what would happen if you rotate a semicircle around an axis, and then be able to find volumes of inscribed spheres, okay? Composite figures as well. All right. Luck on your homework, and I will see you in class.